All right, here starting up for segment two for week one when we're going over momentum. We ended with increasing changes in momentum. Kind of pick up with decreasing momentum because it can do the same thing. You can decrease your change in momentum, which is going to decrease your force. Ways you want to do that is by increasing the amount of time it takes you to change your momentum. Things like we said egg toss. When you grab an egg toss, it's in how you catch a football or catch a baseball. You go with it. You kind of hold it out here, and as you catch it, you absorb it, which is taking the change in momentum still from whatever it had to zero, but you're increasing the amount of time it's coming to zero. And in doing so, you decrease the amount of force impact on it. We did our egg drop. You had to decrease the momentum and try to soften the way it goes in order to reduce the amount of force on the egg so it didn't break. We can look at conservation of momentum, the fact that momentum is conserved as long as there's no external forces acting on it. Your momentum will be conserved in any type of collision. Now, this part was where we talked about collisions, the idea of things hitting each other. So as you just there's no change in momentum if you don't have an external force. And one of the things we talk about that we gave as an example was sitting in a car. If you're inside the car and you push on the dashboard, is that thing going to move? No, you're not going to have a change in momentum because it's an internal force. You can't get it to be moving. There's always that in any momentum is conserved throughout the collision. So whatever your momentum was before the collision has got to equal what your momentum is after the collision minus friction. So it can be an internal one. Here it was shooting a gun or a cannon in this case, as we look at as you shoot the cannon, the momentum is zero before you shoot it. Well, guess what it is after? It's still zero. Didn't change because remember we said momentum is a vector quantity. So you have the cannonball being shot out in this direction with a certain momentum, smaller mass, greater speed, and then you have the cannon going off in the opposite direction that when you add those two things together, they cancel each other out to be zero. The cannon will have less speed but more mass. So law of conservation can be, as long as if there's an internal force, they come out to be zero. That momentum is conserved throughout any type of collision as you go. So we talked about cannonballs being shot, guns being shot. It's the kick that you feel. And when you add the mass of the gun with the kick and the speed of the bullet, that the two momentums will end up being zero. So as you end up going, there's lots of things that we can use with here's just some examples: cars colliding, stars exploding, as far as nuclei, when they go through radioactive decay and give off alpha, gamma, and beta particles. So all of those things will stay conserved throughout. One of the things we always talked about in doing so would be the idea of this collision before and after. And you'd have two types. You'd have an inelastic collision, where there is no change in heat or there is no sound given off. There's basically the momentum before is going to equal the momentum after. And there are perfectly elastic collisions in the subatomic particle that when subatomic particles bump into each other, there's no loss, no heat generated, but usually doesn't occur in the real world as far as the macroscopic. Cars are going to be deformed. They're going to create heat from the friction that's involved in sound. And there's going to be some type of deformation that takes place, and those would be called inelastic collisions. We didn't really focus a lot on inelastic collisions because we wanted to try and keep it simple at the beginning. And as you go through physics and get into it, you start taking into account what's lost. Basically, that is a condensed version of Chapter 7 with momentum. Don't forget to look up the PowerPoints, full version, all the additional stuff I added to it. If you have any questions, feel free to email. It's mark.boer@addisonschools.us.